Hi everyone, Joey PickardtUsed, German audio engineer and guitar player, and today it's again all about building a modern metal tube amplifier. We talked about the power supply and the power amplification stage, and today we are going to have a look at the preamp, at the phase inverter and the effect loop. Let us start. But no, at first the parts have arrived, so I'm showing you a quick video how everything looks, what is inside the package and what I've ordered and what we are going to put into our amplifier. Have fun. First, I think this one is the chassis. So let's have a quick look, but it's not going to be a complete unboxing video. I just want to show you some important parts of the amp. There it is. It's an aluminium chassis, small, with this like 19-inch rack holders, I think they are called in English. Yeah, nice. You can see it's going to be a pretty small amplifier. It's not the full-size head like Marshall heads or the bigger, older ones. It's going to be nearly as small as a lunchbox amplifier, but with output tubes that can handle a bit more of power and will sound bigger, larger, like a 50-watt amplifier mainly. Nice. Okay, then let's start with the big things. We have some heavy boxes here, and I think you can pretty fast assume that this is going to be the transformer. The power transformer, and here it is. Nice, small but heavy. This is a nice chunk metal here with, in Germany we call it Hammerschlag. It's a nice surface that they are using, and it has a nice old-fashioned look, but cool. I think they will look awesome on top of the chassis. Okay, and also you can see the different wires, the smaller ones, because the current is less and the voltage is higher, maybe are high voltage windings, taps and stuff, and the bigger ones are for the heaters, for the lower voltage, high current parts. Okay, I think this is the matching output transformer. This is a nice set of transformers, I think. Looking good. It's not that big, but big enough to make a lot of noise. Nice. And here you can, okay, that's nice. This is the high voltage segment of the transformer, so the center tap and the positive and negative tap, or the push-pull tap for the 400 volts side to connect it to the power tubes. And this one is for the speaker output, so 4 wires, one is the common ground, and 4, 8 and 16 ohms for the different resistance of the speakers. Very nice. And then we have this small filter choke. This one is used in the power supply to filter out some of that hum that is coming in after the capacitor and the rectification, because this is better than resistance to filter out. It has a lower inner resistance, but this is a coil. A coil will always filter high frequencies out, and that is what it is used for. So the first part is not a resistor; it's a filter choke in the power supply to filter out more of that hum, but with less loss of current and voltage drop. Nice small one. Nice, nice, nice. Okay, now preamp tubes, 12 AX7s or ECC 38, 5 ones. So these are going to generate our high gain tone preamp tubes. And I've looked in this box before. Output tubes, the 58, 81s, tubes that sound pretty familiar or compared to the 6L6 GCs. They are pretty near on that sound, but there's a small little difference. I think for me it's in the mid-range. They are pretty more colored in the mid-range. Maybe if you mix 10% of an EL33 into a 6L6, you get a bit more aggressive mids, but not a lot. And I like it really much. This is why I have chosen this tube. And also, this is the cheapest matched pair of tube that you can get from JJ. I think it's because the 6L6 GCs are so similar, but can handle a lot more of output power, but I don't need it. This transformer only handles 36 watts, and they can get it. So it's a nice match, I think. Okay, I think we don't have to go every detail. Two reports for the power supply and the power tube section. Then every small part that we need. Tone capacitors for the signal flow, diodes for rectification in the power supply. The big ones are for 6.3 volts and the small ones are for the high voltage part. Capacitors for the power supply. More caps, small caps for tone issues for the cathode. These are electrolytic capacitors for the cathodes, small ones I think. Yeah, they are. Smaller boards for the preamp assembly. And last but not least, this enormous box. Okay. Preamp tube holders, sockets and shields. And power tube holders. I like them more than these small metal rings that are grabbing into the tube socket with this metal tooth and peeking and scratching out the hell of the tube, because if you change a lot of tubes, because you search for sound or something, then these metal rings are scratching and scratching and scratching if you change the tube, and I like them more. They're going to have a nice look on the amp also, so I decided to go with these ones. Okay, nice to have you back here. I think that output transformer and the power transformer are looking very nice. I can't wait to put it into the amplifier. So, but at first I want to tell you how I designed my preamp stage so that we finally can talk about that turn of gain that should happen later. Okay, I'm sharing my view with you, and there it is. And what you can see here is the preamp. I'm going to take you through the preamp, not through every part like in the other schematics, but so that you can understand why are parts like these here and which values are chosen. And at first we start with the tubes. You can see here 6 ECC 83 triode stages. So here are 3 tubes, double triode systems are they. So included and generating the preamp sound. For orientation, what we can see here on the left, the input mono jack for our guitar plug, and on the right are 2 equalizations. And as you can see up here, this little switch that I'm marking right now is for channel switching. It's not for channel switching, it's for switching in the clean channel to select the clean or the muddy or crunchy sound. And you can see I'm going out at this line, out of this schematics, and over the switch into one equalizer, and the other equalizer section, this downside part here, is getting the real last output of the last tube. So this will be the gain or lead channel equalizer. Okay, enough for orientation. Let's start with the tube design and what we are doing with the power supply and the parts to get the kind of gain that we want to. At first we can see here that there are 2 power supply tabs. So we have a UB4 and UB5 here. The UB4 is in our power supply the voltage that is a bit higher and a bit less filtered than the UB5. The UB5 is the really last part of the power supply. This is the most filtered part with caps and resistors to take care of the really high gain segment at the front, because this signal will be amplified a lot, and we don't want to have any noise from our power supply into our sound, and so this is taken care of. The different voltages are mainly a gain and a character design function. So you can use it to decide how the amplifier is going to be in his character, in his behavior in the gain. So if you take everything the same voltage, then you have a pretty straight through. You have to do a lot with the resistors to get a dynamic or a compressed sound. But if you choose different voltage steps, then you can choose a more dynamic or a more compressed behavior of the preamp. I've done a little Excel sheet to get a better understanding of this for you guys, and let's look into that. So let's first look at these values on the right. I've just built it up 4 trial stages, not the 6. 4 are enough to understand how everything works. And I've done here a little function that is producing an input signal. So if I produce an input signal, let's say 0.1 volt peak to peak from our guitar. If you turn up your volume potty and have passive pickups, you will get mainly a bit more peak to peak, maybe a half volt if you push real hard on the strings, but 0.1 volts is a nice clean soft plate guitar. Let's have a look at this. You can see here's happening something. There is going to be a sine wave that is later a bit louder or a bit higher in its amplification. So, and we have these red ones here. These red ones are related to the values here, and they are representing the maximum voltage that each triode is getting. So not the UB plus, the voltage that is happening on the tube. I know these values are a bit high for operating. It's just a model, okay? So don't claim me on that. It's not only for understanding. These are the voltages that are happening right on that spot here, on the anode of the triode. And as we can see, the later or the steps we go through the triodes, the higher the anode voltage that we are offering for the tubes. And if we now go up with our signal in amplification, so we put a louder signal in it, let's take 0.5, you can see here barely we can see the input signal at the front. Then at the first amplification stage it's a bit louder, second a bit louder, third a bit louder, and so you get the point. We get, every time we pass the tube, one tube, a bit more amplification. You can see here I've drawn a gain factor, and this is pretty low. This is much higher in a real amplifier. It's just to have a good visualization here. You can see it here that a typical ACC 83 or 12X7 will have around maximum 100 of amplification factor, and let's go maybe just for the moment with 10, so it's better to see. I'm putting in 10 volts now at the first triode amplification factor. Okay, so from this to this we are amplifying 10 times our sine wave, and you can see the complete res has three times the amplification, but the last tube is going to saturate our signal that much that the top flattens and we get a little bit of distortion. If we go further and further, or let's stay with that here. Let's say our tubes are very bad and don't have that much of amplification factor. Then we can put maybe a tube screamer in front of the amp, and we are getting out, let's say, 5 volts. So we turn the level up of that little pedal, distortion down, tone does not interest us at the moment, and we boost the signal, just a clean volume boost. And then maybe this amp in this operation will sound like this. Crunchy but not really distorted. And now with that signal pushed, you can see there's a lot of distortion going on, and the other triode stages, except for the first one, are going into clipping mode. So they are distorting, and for that now our sound will maybe sound like this. Okay, I think you get the point. Each time we get amplification. Let's now have a look. Let's say we have 12 AX7s with around 60 to 70 amplification factor. So I'm putting in maybe 60, 60, 70, 70. And our input signal is just that from our guitar that I mentioned at first. So we can't see it here really, our input signal, but you can see the first stage won't distort at all. It will amplify, but it won't distort at all. And here, the second is distorting already, and the other ones are getting closer to a rectangle. A rectangle is a sine wave that is pushed to its edges, and what this means in the frequency spectrum is that this sine wave, which is in a frequency spectrum, only just one line at maybe 1 kilohertz. Then if we push and push and push, harmonic distortion will occur at multiple factors of that based frequency. So we get maybe at 2 kilohertz, at 3, at 4, at 5, different levels of distortion, and how that spectrum is formed is the main factor how the gain stage will sound later. The mixture of K2 and K3, this both distortion factors, is the main way to form a fuzz sound or a nice distorted tight metal sound. This knowledge is all between here and between scientific calculations for example, Fourier analysis. But let's stay with that. I think you get the point how the sound design is made at this amplifier with the power supply. That is just one part, but this is a part that I have not seen many often, and I think it's a good way to visualize it. Okay, let's have a look at the gain poties or our input volume, input gain at the amplifier. We can see it here and here for clean and lead. So I'm switching with a channel switcher, with it's a relay between this both potentiometers, and you can see our signal flow is going past the resistor and a capacitor. This is typically to filter out a bit bass frequencies and pass through a bit more higher frequencies, because capacitors are passing high frequencies and the lower have to take the way through that pretty large resistance. You can also see at the gain potentiometer I'm performing something quite like that. I'm performing a bypass with a capacitor to get more high frequencies while the value is regulated, and I'm compensating a bit the used 500 kilo ohms, it should say, not mega ohms, so this is better. Okay, same as here. And when we pass that, maybe I'm changing that value of this resistor later, but for now it's better. I've learned it from other amps from my last amps, that it's better to have here a resistor for gain regulation, so it's smoother in how the gain is adjusted. Okay, we've looked now at the input gain, how the power supply is working for the preamp and in the equalization, but I've not talked about the very first input. So here, that resistor on the input jack is for, if I disconnect my guitar, then there will be a definite load against ground, so that we don't have any weird noises into our preamplifier, because there is not a definite resistance against ground. Down here we can see a 100 kilo ohm blocking resistor, gate blocking, to get out of maybe interfering radio frequencies or something like that, because the gate has a very high input impedance, and if you don't use such a blocking resistor at the very first input or the first stages, you will get radio interference with AM radio stations and something like that. And also a definition resistor with 1 mech against ground to get a defined higher voltage than the... No, it's not a higher voltage, it's just to define the working point with the cathode and the cathode bypass capacitor that we can see down here. Oh wait, I have to quit this. Okay, that's better. Okay, here we have the first cathode resistor and cathode bypass cap. So the bypass cap is for that we can bypass frequencies, but the DC voltage is blocked and has to pass this resistor. So what we are getting is DC voltages are happening here. So we have maybe 1-2 volts at the cathode, and it's a bit higher than our gate. And for that, our gate is relatively a bit lower than our cathode resistor, our cathode voltage. And this is needed, because the nearer we get to 0 volt from cathode, from gate to cathode, the higher the amplification will be from our tube, and we're getting into clipping if we do it over 0 volt, an undefined sector it is. The sector we want to with our signal, but we don't want to have the operating point of the tube outside of the 0 voltage range. So it's a good operating voltage between, I say, -1 volt to -10 volt, around there, for ECC 83s. But the frequencies can pass here, and this is allowing the tube to get a much higher amplification factor. Let's talk about the size of the capacitor. Here we have 1 microfarad. If we change the capacitance here to larger, then more low frequencies will pass, and less. If we change to less, so maybe 100 nanofarads, then less low frequencies will pass. And what happens is that we get a lower amplification range for low frequencies, and somewhere in our frequency range the amplification factor is growing at the point where this resistor is going to be pass through high frequencies. So the amplification is not zero below this passing point and not infinite above. It's just having two different factors where the higher frequencies are more amplified. And this is used for sound design also. We want in the modern metal amp a rich, high frequency loaded sound and not a very damp and fuzzy, very bassy, distorted sound. So maybe it's good. I think the bass players under us will know it. If you have, wait, let me. Such an pedal we can blend clean and distorted sound together, because it's interesting for bass players and for guitar players and down tunings also, to get a clean low string sound. It's like a piano side that is mixed to the gain sound. So it's we have an interest in low gain for the very low frequencies, that we nearly get a clean or just a crunch sound. And this points of this capacitors and the passing capacitors in the signal way will allow us to design where that point is and how the whole preamp is interacting with our low frequencies, so that we in some get a really ass-tight bottom end, but a really soaking wet high frequency distortion, like we know it from, I don't know, the VH4 or the Diezel Herbert. These are nice soaking but dynamic sounds with a pretty tight low end. The Mesa Boogie is getting tighter if we use a tube screamer, and the tube screamer is doing pretty much the same that we are doing in my preamp here. We are filtering out a lot of low frequencies before we do amplification. The Mark series of Mesa Boogie is using this. The first equalizer from the channel is before the gain stages, for most of the part of the gain stages. So if you lower out the bass frequencies and put in mids and highs, then you're doing pretty much the same as we do here, filtering out before we getting distorted. And after that we have a second equalizer, if you want that, a channel equalizer for adjusting the kind of sound that we are like and that is matching our cabinets. Okay, not much time is left. Let's have a look over the whole preamp near at the later tube amp sections, and you can see pretty much everywhere we find this capacitors and a value around 1 to 2K at the cathodes. Only on this stage, the third stage, there is no capacitor and 33K. So we learned that this is maybe producing a higher voltage here, so a lower or a higher gap between the minus set voltage for the gate and the cathode. So this tube is operating at the lower amplification and at the other operating point, I would call it. And as the operating point where it's fixed and the operating curve of the tube is not linear, and it's getting more flattened out in the low voltages, so to lower minus voltages, we are getting a lot of distortion, and we are pushing with the tubes before that really hard this tube stage. And this is done in the Mesa Boogie rectifier and the PV5150 and a lot of other amplifiers like the Soldano SLO100. And this is a key for that kind of raw modern sound. Okay, now we have, I think, the main issues and parts. What I thought to myself would be nice is to put in a switch where I can change the character of the gain stage or of the lead channel, and here I'm doing it on the anode resistors of the fourth tube stage, and I'm halvening out the value, so from 200k to 100k, in just shortening out this resistor. And what will happen here is we get a higher operating point of the anode, and looking back to our sheet, something like this will happen. This point, operating point of the tube, will change to higher values. We will have a bit less gain overall, but more dynamic. So this will be interesting to change, to switch around, hopefully. Okay, I think that's enough for today. Phase inverter and effect loop I will put in the next video because the preamp took too long, I think. What is also interesting, I'm showing in the next video, I think, is the noise gate. But thanks for now.